live. All right, so welcome, Doug, from Vericoin to the SF Bitcoin Devs Mountain View meetup. We're going to get a deep dive into all things altcoin and do an anatomy of altcoin with Vericoin as the altcoin. This meetup and in the month of August has been sponsored by Peer Nova. They've been kind enough to pony up some drinks for us. I'm going to go through the room and have each individual maybe do a quick 1-minute introduction. We will start with you. Yes. Yeah.
Okay. So my background is basically like C, C++, embedded. I work with RFID, bit, but you know, other things too, like printers or things that maybe involve RFOS or just like ThreadX, for example, for RFOS. I'm familiar with Bitcoin. I actually have a a wallet that's online, so I've used it just a little bit. I just have a very small amount of money in there. But I'm curious. This is my first time attending this group. I'm just kind of curious about what people are doing here, maybe what they're developing, and just kind of what I can learn about it and what the future might be.
Cool. And then we'll go to the next person in the room. Let me see if I can get this. Yeah. Okay.
Hi, my name is Tata. I just joined the Bitcoin-related startup company. And my background is OS, operating system security, network security, Ruby on Rails, web app development, big data, machine learning, data analytics, and search. I have lots of stuff.
Okay.
I'm learning Bitcoin.
Hi, my name is Avery. I'm a student at Stanford. I'm currently in the computer science department as an undergrad. And this summer, I'm a data science intern at UMA, which is a smart homegrown company. And I'm interested in becoming a data scientist.
Cool. So we'll go around here then.
Oh, hi.
Yeah.
Cool. My name is Ben. It's my first time here. I've been in Bitcoin for about 2 years, more than 2 years, and I'm just start with a project close to a few weeks ago.
Hi, I'm Joseph. Been to this meetup a few times. So always trying to learn more and more about the details of Bitcoin.
And my name is Sriram. I'm the co-organizer of this meetup. In the daytime, I run a blockchain-based startup that helps to bring efficiencies into the supply chain. And I'm interested in learning all about the anatomy of an altcoin. With that, I'm going to let you have the floor, Doug. And I'm sure we're going to have a few more people. They'll just saunter in as and when they make it. Cool. You've got the floor, Doug. Hello. I think, give me a minute. We can't seem to hear you. Is your mic on? Hello? Can you hear me now? So Doug is not muted. My volume? Hello, Doug, can you hear me? Well, we can't seem to hear you. We can't seem to hear you, Doug. Can you hear us? Oh, okay. 1 minute. by the way, this chat. If you can hear us, you can go on chat and chat. That's one finger. Okay, he exited. Okay.
You want to give the URL for tests you
Yes, I will. Oh, I should put it up on the meetup page, which I did not. Give me a minute. This is the event page. Okay. It's on the Google. It's on the meetup page.
Yes.
Very slow, right? Yeah. I mean, okay. He cut out. Let's see if he comes back and let me go invite him.
Can you hear me now?
Yes, we can hear you now.
Okay, great.
Okay, Doug.
Yes. You can hear me?
The floor is yours. Yeah, we can hear you.
Okay, thank you. Thank you, great. I really appreciate you guys inviting me to this talk. I'm always excited to talk about digital currency with other interested people. First, I want to apologize. I'm actually doing a Google Hangout from a car right now because I got stuck in traffic and wasn't able to get home in time to do the Google Hangout not from a car. But one of the good things about having this technology is that you can do it anywhere you are. But
well,
so,
Doug, your audio is coming in and going out. It's kind of hard to hear you. Maybe you kept the mic closer or something. I don't know. We could try that.
How's this? Is this better?
Well, why don't you speak a string of words, and we can find out if it's better.
Okay. How does this sound to you guys? Is that clear?
No, it isn't better.
It isn't better.
Yeah. Oh, why can't you? Yeah. Maybe you could just. Why don't you call me on my cell phone, and we could have your face up here, mute you, and then we could sort of hear you on the phone. That's a better idea. Here's my cell phone. It's on the chat. And I'll just put it on speaker.
Okay. So I'll hang up.
I just sent you my cell phone on the chat. If you could call me, I'll put you on speaker, and I think we should be in good shape.
Okay.
The only thing is the broadcast won't save, but yeah, right now it doesn't matter. We'll just.
You can also add in the
Yeah.
export.
Is the phone?
Google Hangout, I think
Let's see. Maybe he's doing that.
you just go.
Yeah.
Better something than nothing.
I know. Right now we want to know, it's okay if you don't get the video. It's never been smooth, this Google Plus Hangout. Last week, it's something or the other.
I think it's the. I use it a bit.
Really? It's the internet here, huh? Yes.
Okay, because then you should have the last one.
Yeah, but I don't think it's the internet. I think. Oh, yeah. Hi, Doug. It's better. I'm going to put the volume up. When you talk, let's see if everyone can hear.
Okay.
Yeah.
Can everyone hear me?
I think so.
Okay. All right. I'll start from the top quickly. I just want to thank everyone at the Bitcoin Developers Meetup in San Francisco. I'm sorry. I can't remember the. What's the location you guys are?
We're in Mountain View at the Hacker Dojo.
Yeah, that's right. Thank you for inviting me to the meeting at the Hacker Dojo. I'm always happy to talk with digital currency about digital currency with anyone who is interested. And I do the audio problems might be on my end. I apologize for that. I got stuck in traffic today and wasn't able to get home in time to make the hangout here. I was hoping I would be able to do the hangout from my car, but it could be that my service isn't quite good enough. But I'm glad we're able to nonetheless do the talk.
Yeah, I think we've got a good system going. We just can't see you, but that's all right. And you're talking into a phone. The phone is talking into the Google Hangout, so it should also get recorded on YouTube. I think all of us can hear you, so go right ahead. Don't feel, it's working.
Great. Thank you. So I'll go into some of the points that were mentioned on the website about what I'm going to talk about. I'll quickly just mention to you guys what I am going to talk about. I'm going to go through the code changes from Vericoin back to Bitcoin, and basically the kind of the ancestral lineage of the code. I'm going to talk a little bit about proof of stake, our implementation of it generally. I'm going to go into some details about our network strengths are, what we're trying to make better about it. I'm going to talk about also some features that we have, some tools that make the process of using digital currency, which is the primary goal, easier. And I'm also going to talk about some of the challenges of developing a digital currency and all the intricacies that go along with it. And then at the end, I'm going to talk a little bit about tips and suggestions to those that are interested in particular developing a digital currency, or alternatively just getting involved in digital currency. Me and Pat and Dave, the three of us are the core developers for Vericoin, and we started Vericoin in May 10th of this year. That was our launch date, and we did the hybrid proof of work, proof of stake system. And essentially what that is the proof of work algorithm for verifying transactions using different hashing algorithms. In the case of Bitcoin, it's SHA-256. In the case of Litecoin, the hashing algorithm is Script. We also used Script. So we did a proof of work Script hashing algorithm period for 1 week as an initial distribution phase of the vast majority of the complete coin supply that would be released into the market. So this is relating this to Bitcoin. This is basically like taking almost like the first 15 to 20 years of Bitcoin and putting it on fast forward, because the proof of work reward halves every 4 years for Bitcoin. So it's deflationary overall, but currently there's about 10% inflation of Bitcoin into the market every year due to mining, and that has a halving period of 4 years. So we kind of had that sort of initial distribution phase of Bitcoin in a very short period of time, and ultimately we developed a proof of stake currency, and I'll get into what the details of that are. But essentially, we use the proof of work period as a fair as possible distribution distribution phase for a proof of stake currency. But ultimately, our code ancestry is as follows. Bitcoin, obviously the first digital currency, and even though it's the first, it's still the best in many ways, and is not any more vulnerable than it was when it began. In fact, most would say that the network is actually more secure than it ever has been. And this is the beauty of the design. As the network becomes more distributed, the protocol becomes more and more secure. So the ancestry of our code is as follows. Bitcoin is the vast majority of the code. The code base for Vericoin is based on Bitcoin. And we implemented the proof of stake system of Peercoin. And I'll get into a little bit of details on that. We implemented the script hashing algorithm from NovaCoin, and we implemented the short proof of work distribution phase structure from Blackcoin. So we have basically a Bitcoin, Peercoin, NovaCoin, Blackcoin code ancestry, and then we made some modifications to the proof of stake protocol as well. And I'll start talking now a bit about what proof of stake is and how we implement it, and so forth. So proof of stake is really the only established, well-tested, successful in numerous cases alternative to proof of work. Instead of the competition for earning a reward for signing transactions, for confirming transactions in the network, instead of that reward taking place due to a competition between computational power executing on a hashing algorithm, in the case of proof of stake, the node that's selected to verify and confirm a transaction for the network is randomly chosen with a weighting, and that weight, the weight of that random choice is predominantly composed of the number of coins that node already owns, and also how long it's been since that node and the coins that it's staking on the network, which is where the term comes from, when the last time those staked coins received in most proof of stake currencies is an interest payment, or successfully signed a transaction and verified it on the blockchain, and then it was distributed across the network. So instead of the competition being between computational power executing on a hashing algorithm, there is hashing. It's essentially the same. The difference is only in the emphasis of the competition. The way the node is chosen is dependent on the number of coins and when the last time those coins successfully signed a transaction. And the terminology is the number of coins staked and the coin age. And the coin age is basically just the coin age is reset in time, in hours, when a fraction of the coins that are on a node successfully are staked and used to verify a transaction. So once some fraction, so say I have 10 coins in my wallet, 5 of them at a given time were staked for numerous reasons. Those 5 were used to confirm a transaction. The computation was between coins, not computational power. Once those 5 coins have confirmed the transaction and the network accepts it, then those 5 coins now have their age has been reset, and they essentially go to the back of the queue for the next time that a transaction can be affirmed by a proof of stake node. So this is there's a lot of benefits to this system. This is why we went with it for Vericoin. One of the biggest ones is because the computation is not between computational power, it's essentially between the number of coins, the weighted randomness of having the ability to sign a transaction. Because the competition is not computational power, there is not a horse race for having the most computational power. And the downside to having a horse race for computational power is the energy consumption. There is, I don't know what the current numbers are actually. I should look this up, but the energy costs required to run the Bitcoin infrastructure is extremely significant. And after some time, when Bitcoin is even more widely accepted, this will become more and more the case, and it could be a limitation ultimately on the Bitcoin network where electricity consumption is a factor in the reach that the network could potentially have, especially as you go into underdeveloped countries and countries with less infrastructure. So one of the downsides of the proof of work system is the energy consumption requirements. The mining hardware is getting more and more efficient over time. There's only so much one can do to minimize energy costs for some degree of work. So one of the main benefits of the proof of stake system is there is essentially as much energy consumption as it takes to run any networking torrent-like application, for instance, like a BitTorrent application. That's about as much energy as you need to confirm a transaction, to sign a transaction in a proof of stake network. You basically just have to have your wallet open. You have to have some coins in it. You have to have not signed a transaction recently for the probability to be high that you successfully sign a transaction. And there is hashing that takes place, but the difficulty is so extremely low that it's a breeze for the processor, the CPU in this case, to find the right hash to successfully sign a transaction. So one of the main reasons we went with proof of stake is the fact that it consumes a lot less energy, but also because there's not a computational race, a power race, then there also isn't significant lag time that could potentially occur in the case of a difficulty adjustment happening rapidly. So for instance, if a big mining farm comes online and has, let's say, 5% of the computational power of the Bitcoin network, and adds a new level of hashing, total computational hashing power to the network, and then comes off, the difficulty readjustment can lag. I mean, in the case of Bitcoin, it does lag. The difficulty readjustment is 14 days. So in the context of a 14-day difficulty readjustment, one also to some extent needs to have a broader window for confirming, fully confirming the transactions. And in the case of Bitcoin, a full confirmation is on average about 10 minutes. So due to the significance of the design of Bitcoin, it's an extremely conservative protocol. In retrospect, in the beginning, it was the only protocol and a great successful proof of principle, and still is today. But in just a few years later, in the current context, it's an extremely conservative protocol, which would be the prudent thing to do when you're developing something brand new. But there is limitations. Primarily, the limitations relate to energy consumption, but also confirmation time for the transactions. So proof of stake coins typically have a much shorter confirmation time window. Proof of work coins can as well, though there is a little bit more difficulty minimizing the time lapse depending on the difficulty adjustment algorithm and such. But in the case of Vericoin, confirmation time is on average less than 1 minute. So we kind of are framing it and thinking about it this way, and I'll sum up this point. We consider Bitcoin to be the digital currency gold standard. It's a conservative protocol. The protocol requires a significant investment in computational hardware to successfully win proof of work rewards. So the miners have to sell Bitcoin for a certain price just to compensate themselves for the electricity consumption and the ultimate cost of the hardware that they purchased. And in that sense, in addition to the deflationary format where the coin reward is halved every 4 years, the overall deflationary structure, the entire system is basically modeled after gold mining, and this is why the proof of work is called mining, because it's basically analogous to it. And so we think about it in this context. Bitcoin is the gold standard of digital currency. It's highly valuable. It's a scarce commodity. It has a lower supply. It can withstand significant network outages due to its wide acceptance, but also due to the longer confirmation time window, and it will probably always be in the context of our world today. When we have computers, we have smartphones. We're not 30 to 50 years out, and things are completely different. In the context of our modern world today, I suspect Bitcoin will always be kind of like the gold standard digital currency. And we're kind of orienting Vericoin as the not so much a precious commodity, but more like a store of value. So we're targeting more so like a digital cash format, where its confirmation time is very quick, the energy consumption is very low, it's very compatible with everyday use. You don't have to, there isn't occasional lags in confirmation time that require you to wait at a store longer than a minute, let's say. It's more compatible. We think the proof of stake system is more compatible with everyday use. And some of the downsides of the proof of stake system we actually experienced directly, and that is that because coin ownership is one of the most significant things in determining what node signs the transaction block, it's important that coin ownership is well distributed. And on the market, if you were able to purchase a proof of stake coin, to be able, so in the context of Vericoin, I mean, you would have to spend well over $1 million to purchase at a given moment enough Vericoin to have a significant stake weight that would allow you to sign multiple transactions onto the blockchain in sequence. But as you actually start purchasing proof of stake coins in the market, the price is going to rise. So it almost becomes it's a slippery slope of buying more and more costly coins to essentially try and game the system, and there's very little incentive. However, it is easier potentially to do that by just buying coins on the market than to invest in significant hardware and set up a server farm or have collusion with multiple server farms to try and reach, which is the attackable point for all the currencies of 51%, or most of the currencies, 51% of the consensus. So The downside of the proof of stake currency mostly is that all you have to do is get a lot of coins to potentially have greater than 51% consensus and manipulate to your own will the blockchain. However, the benefit on that same point to having a proof of stake system is one could invest a significant amount of money in mining hardware for Bitcoin, get some large percent of the network hash rate, and if they're unsuccessful in gaining 51% control of Bitcoin, they could easily just take that same mining hardware and switch it over to another SHA-256 coin, which often happens, and gain 51% control of a smaller coin. So this is a number of factors, pros and cons regarding proof of work, proof of stake. Ultimately, it's kind of they're very similar. The primary differences are between coin and computational power. We experienced an extreme scenario, which will likely go down in some of the history books of digital currency, where 30% of the coins were hacked from an exchange, and basically a bad actor had a significant share of the coins. So that's an extreme scenario that put Vericoin in a potentially vulnerable position. We now, moving forward, are making a point to further decentralization in our infrastructure, because the strength of the digital currency networks is decentralization. Is the fact that there is no central point of attack or central point of failure. One of the biggest weaknesses in all coins, all digital currency coins, is that the exchanges themselves are centralized. So because the coins were centralized in one place, a significant share of the coins were centralized in one place, the hacker was able to potentially attack the network. And we took extreme caution in handling that situation and did what we thought our only option was. And looking back, we agree with this, and that is we rolled back to a point in time, which was less than 18 hours just before the hack, such that the hacker no longer had the opportunity to perform a 51% attack on the coin. So we experienced firsthand what a potential limitation of the proof of stake system is. However, on the opposite end of that spectrum, and then I'll move beyond proof of stake, is this. Proof of stake consensus, meaning you have a node on the network, it has some number of coins, and the number of coins that are used to confirm a transaction in conjunction with the time they last confirmed a transaction determines the probability of being able to sign a transaction for the network. And 95% of the time, our network is actually significantly decentralized, where the most powerful node has only 17% or so of the stake weight. So what this basically means is, contrast that to the proof of work system, and quite often you'll see large mining farms approach 51%, and then they'll basically stop accepting new miners onto their server, and they'll kind of monitor and control, make sure they don't get closer to that consensus threshold. But they're often in the 30s, in the 40%, and then sometimes approaching 15 and 51%. And 51% has been breached multiple times, so no one knows of any instance in the case of Bitcoin where that was abused. So on the one hand, you have pros and cons of the proof of stake, proof of work system. But in the context of barring extreme circumstances, the proof of stake system is actually much easier to maintain in a completely decentralized format, meaning there is not pooled resources signing transactions because there's no incentive to. The probability of receiving a reward is dependent on the number of coins in a node that are able to be staked. So in the case of proof of work, there's actually an incentive to pool resources, and the reason being is because you increase your odds of getting some fraction of a reward, where the proof of stake system completely solves that problem. There's no incentive to pooling resources, or if there is, it's extremely small incentive that just doesn't show any real benefit. So that's an overview of some of the aspects of the code ancestry from Bitcoin to proof of stake to Vericoin. We're going to go a little bit into now some of the modifications we made to the protocol, the proof of stake protocol, in addition to some of the features we have, and then I'll go further. Is there any questions up until this point?
No, I think you've given us a very good overview. Anybody else have questions? I just wanted to know NovaCoin and BlackCoin. I guess you're going to get into that as to exactly what it is that, which parts of it you used, and how many coins did you actually mine in that first week, and what is the total number of coins that are available to you? And how old are you guys? When did you first sort of launch? And the number of nodes you currently have running in your proof of stake. So those are my questions till now.
Sure. So we have about 5,600 potential nodes. So we have 5,600 wallet addresses, but it's hard to say exactly how many nodes we have at this time. But we definitely have over 3,000 nodes in the network right now. We launched on May 10th of this year, so we're just a few months old. And what we did was we forked from BlackCoin. So BlackCoin had incorporated code sources from Bitcoin, Peercoin, and NovaCoin, and we forked from BlackCoin. So we adopted most of the proof of stake implementations that BlackCoin had. We changed we changed some minor things, but primarily what we changed was the way the amount of stake reward, which is in the form of an interest payment, we changed the way the stake reward is calculated. And what we did for that is we actually used a feedback mechanism from the network, and that feedback mechanism is the total network stake weight. So that means what's the total number of coins that are currently available to receive interest and sign a transaction in conjunction with the coin age, like I described earlier. So the total network weight is basically how active is the network, how many nodes are participating is a major factor. How many nodes are participating in a potential transaction confirmation? And so we use this stake weight value, and we feed that back into the interest calculation. And for every block, we're adjusting dynamically using a logarithmic formula, which is a bunch of constants that put that set the interest between realistically 1.5% and 2.5%, where the variable is the network stake weight. And the reason we implemented this is because we wanted a mechanism. We want to incentivize staking coins. We want people to have their coins in their wallets, and we want people to have their wallets open. And when they're doing that, they're an active node in the network, and they can sign transactions. And the more people that are doing that, the more stable, the more secure, the more decentralized the network is. So we want to incentivize people to have their wallets open and active. And we can do that with them earning interest on the number of coins that they have. But at the same time, we don't want to over-incentivize, meaning people love having their wallet open, but we're inflating the currency so much that we're ultimately slowly killing the value. So we have a logarithmic formula whose variable, which is a combination of constants. If you're interested, you can email me and I can point you to the location in the GitHub where this formula is. But the variable is the network stake weight, and the concept here is as follows. The concept here is as follows. The higher the network stake weight, the more secure the network is, the more decentralized the network is. So the more nodes there are in the network, and the more stable the entire network is from the ground up. So we want to incentivize that state. We also want to minimize the periods of time where the wallets are not active. So we want to minimize the time frames where people do not have a significant amount of coin in active wallets across the network, because basically the network becomes potentially more vulnerable. You can get desyncing issues, and the currency is definitely less decentralized. You could have nodes potentially running off on their own chain. So we want to maximize the incentive for staking, but we want to minimize the increase in inflation. So we made the interest proportional to the stake weight, such that the more people that have their wallets open, the higher the interest rate is for everyone. And that's when we start approaching about 2.5%. And then if there are fewer nodes on the network that are active, we start the formula calculates the lower interest goes to about a minimum of 1.5% typically. And we consider this basically a feedback loop between the network and the users. And it seems to be successful because what we have is a situation where people are earning interest on their coins. They're also telling each other they're kind of incentivizing each other, communicating with each other. You know, put your coin in the wallet, make sure your wallet is active and earning interest because it benefits everyone.
So the earning of interest, if I might interrupt for a minute, earning of interest, is that the payout for each block, and that sort of goes based on stake?
Yes.
And you issue new coin for interest, is that? And 1.5% is annualized per block?
It's annualized.
It's annualized.
Yeah.
Okay.
So, and the just like in proof of work, the proof of work reward is a minting of coins. So the brand new coins that are coming onto the market are due to mine. In the case of proof of stake, the interest payments are minting new coins and annualized interest rate. So we launched on May 10th. We had a 7-day proof of work period, and in that period we distributed into the marketplace via mining competition. 26.7 million Vericoin, and since then I think we're up to nodes in the network active in staking. So we have a significant network stake with, and because of that, it becomes more difficult for any one entity to gain a share of the network that's significant enough to potentially manipulate the blockchain.
Got it.
And as in proof of work systems, the bigger the network gets, the more safe.
We have another question. Just a moment.
Yeah. Hi, Doug. In proof of stake, you're saying people stake their coins. So so per block, if someone say has 10 coins in one block, they might decide to stake 1 coin. In the next block, they might decide to stake 3 coins. Is that how it works?
So yes, you can in the software, in all the different iterations of the software, you can choose, except for the Android wallet, which currently does not stake, though we're working on that. But all the desktop iterations of the wallet, you can choose the number of coins that you allow for staking to take place with. So you can always reserve some share of your coins that will not be staked. The confirmation, the full confirmation time for a stake reward is 8 hours. So basically, what happens is if you are actually staking some share of your coin, they can potentially be unavailable to remove from your wallet in a maximum of 8-hour time period. So some people do opt to reserve certain coins for no staking, but the actual number of coins that are staking at any given moment by default is dependent on the total number of coins you have, and what is mostly actually dependent on when you last earned a stake reward, because that's the coin age factor. So, for instance, if you bought 10 coins and you earned interest on them, and then you bought another 10 coins and you didn't earn interest on those the new coins that you just got, the new set of 10, they're going to be staked first because of the coin age. So it's basically automatically set up so that you're always staking your newest coins, or the coins with the lowest coin age. So because of that, you'll see the numbers of coins that in your wallet that are actually staking fluctuate depending on when you receive the coins in your wallet, and so on.
Okay, thanks.
Cool. So, yeah, I think we understood staking and proof of stake and Vericoin kind of. People are, I'd like a little broader as to why do you think of starting a new coin? And if people wanted to start a new coin, what would be the steps that they would undertake? And do you think the coin launch was successful?
Okay, yes. So we actually started Vericoin because we wanted to create a digital currency that implemented 100% proof of stake system for the reasons I mentioned previously. But also, our emphasis primarily is making things as easy to use as possible. So we're trying to really drive home in our development different features that make the technology more accessible to more people, and that's our main focus. And I'll go into a number of ways we're doing that in a moment. I do think that our launch was successful. We had so in the proof of stake system, there's prior to this hybrid approach that Blackcoin did, where they had a short proof of work period. Prior to that, the 100% proof of stake coins were typically some sort of market sale for the because we wanted the competition for the market supply to not just be dependent on like financial resources. So we thought the proof of work system for the distribution phase was better. And it turned out it was extremely fair. As an example, all three of the developers started mining actually shortly after we launched, because I was in the midst of still compiling the Windows wallet, and we had launched the new blockchain on GitHub, and anyone was free to compile themselves and start mining in the downtime while the Windows wallet was compiling. There's actually people that started mining even before us, and we made it a point to not mine until we had the Windows wallet and the Linux wallet. And at launch, we didn't actually have a Mac wallet. A few days later, we worked with someone to get the Mac wallet compiled. But we did have a fair launch, and that's evidenced by the fact that there was actually many people mining before we even did. And there was, right at the launch, there was about maybe, based on the numbers in the pools that popped up, we didn't launch with a pool, but some third parties launched a pool for us right at launch. We had maybe 40, 50 people mining right in the very beginning, and then that number quickly escalated to hundreds, and the distribution was pretty fair early on. And then what happens is, you'll hit some sort of peak in the market, relative peak, and then a lot of the miners will sell the coin or some fraction of the coin to pay off their costs mostly. So the initial phase of miners that we had at launch was they mostly were no longer Vericoin holders after like the first week and a half or so. So then the mining period ended. The early miners, the vast majority of them had sold off, and those coins were essentially sold onto the marketplace. And then new investors came. We switched to proof of stake. Now the only way to really get Vericoin was through purchasing it on the market, and most of the supply was sold by the early miners to the new investors. So we kind of smoothly switched based on just market dynamics from a proof of work mining fractioning of the total coin supply to a market-based supply and demand proof of stake system, and almost purely market-based in the context of proof of stake. So we do think the launch was successful. It's actually one of the things that I'll mention regarding what the challenges that take place in launching currency is when the currency is new and you're in a proof of work period. You can easily have situations where the network hash rate abruptly changes, and sometimes the blockchain will be forked at that point. That happened to us multiple times in the proof of work period. That happens to most coins in the very beginning. And the reason is because you have some mining farms that have significant hashing power, and you have this new coin that has this small, relatively vulnerable network. So we had multiple occasions in the very early proof of work period where we had multiple forks, and in that situation you really have no choice but to just choose the fork that has the longest chain as the consensus, because that means there's a greater number of nodes on that fork. So if you're thinking about launching a digital currency, be prepared for some, depending on your hashing algorithm, it can vary, but definitely be prepared for some wild swings in the network hash power, and then having to compensate for that when certain nodes are on separate forks. Then you basically have to go into the code, put in checkpoints for the longest blockchain, which is the closest thing you have to a consensus, and then suggest everyone update to the new wallet, which preserves the longest fork and abandons the others. This happens really only in the very early stages of proof of work, maybe in the first few days, especially. But that's one tip, one thing to be mindful of, and also one challenge when launching a coin. But that's pretty much a standard problem. And so in the context of the normal challenges that occur with the coin launch, our launch was successful. We had a nice distribution, a surprisingly good distribution of coin across the nodes shortly after the proof of work period ended, and most of the miners sold off the coin, and the price was somewhat volatile, so you got people getting in at different prices and such. So it was kind of a nice transition, even though it was a nice transition on the market side, even though there was a particular block 20,160, where we turned off proof of work. So we had actually a hybrid coin that had active both proof of work and proof of stake for the first week. So you could stake your coins and you could mine new coins. And then at the 20,160th block, which is basically which was about a week, the proof of work functionality of the digital currency was shut down. We didn't have to upgrade the walls or anything. That was hard coded into the code. That block was the last block where proof of work was accepted. And
Got it.
And then basically the entire code that is truly originates from Bitcoin regarding mining was basically shut down, and then what we were left with was the proof of stake system.
Got it.
Which is mostly PureCoin's invention, and their implementation really didn't change much at all, except for some of the confirmation times and the variable interest. And Novacoin and Blackcoin similar there. They both at the time had a proof of stake system very similar to PureCoin's. Though Blackcoin has made some changes to their protocol recently.
One thing I wanted to check, Doug, was you're saying that some investors came into Vericoin and then you changed it to proof of stake?
I'm sorry?
Before the proof of stake, the proof of stake came about because some investors came in and then you chose proof of stake?
No, I'm sorry if what I said was confusing. No, right from launch, we were always going to be a proof of stake system.
Okay.
And written into the code right at launch was the proof of work period would end at a certain block.
Okay.
And once that occurred, then we switched into our actual intention, which was to be 100% proof of stake coin.
Okay.
But we used the proof of work period in the first 7 days just for a fair distribution of the coin.
Okay, thanks.
So if I take this one step forward, I noticed that you want to be like digital cash. You want to make it really simple. You've got a credit card on your homepage. You talk about Veribit, VeriSMS, VeriSend, earn interest.
Yeah.
Also, I noticed that your market cap sort of in the last 30 days has dropped a bit. So if you're going to be just a transaction coin, what's the incentive from the coin holders? I mean, except they would sort of earn interest, I guess. And more interestingly, I'd like to know what inroads you're making at the transaction end, because I think that's very interesting. One of the reasons why I wanted to talk to you in the first place, introducing Vericard, your coins. I mean, could you talk a little more about that? Because besides Zappo, I think you're the only guys, at least as of date, doing something like this.
Right, and that's another. Yeah, definitely. I wanted to get into this. One of the tips that I'll give anyone interested in developing coins is one of the things you do have to figure out, because there's so much competition. The competition is vast in the digital currency space right now. There's new coins, multiple brand new coins every day. So you do have to have a strategy on where your niche is. You know, what purpose are you going to serve that's not going to just basically dilute digital currency generally? Like, what can you bring to the table that's not just going to replicate other currencies at the expense of digital currency generally? And we actually thought a lot about this, and I'll go into exactly what you mentioned. So a quick overview is the features that we have for accessibility and usability that are unique. Some coins, so I'll go into each one. We have an SMS wallet system. So we have cell phone network numbers that are designated to receive commands from the SMS system. So you could text in an SMS format, which basically every cell phone these days has, not a smartphone. It doesn't have to be a smartphone, which is one of the benefits of it. You could text the command such as balance to your local gateway Vericoin wallet gateway number, and we have a number of numbers all over the world, and it'll tell you what your balance of Vericoin is in your SMS wallet. And you can send some amount of Vericoin to a phone number, and it'll send that amount of Vericoin out of your SMS wallet to that phone number. If that phone number doesn't have a wallet address already, the system will automatically generate a new one, and it'll receive the coin at that newly generated address. And these addresses are actual Vericoin wallet addresses. They're on the SMS node system. This is not designed for security. There is potential loopholes in spoofing phone numbers and such in an SMS system, but basically what it makes possible is it makes it possible for people in countries with extremely little infrastructure to be able to have access to Vericoin at all. It makes it possible for someone who doesn't and has never owned a computer to receive Vericoin and send it on. One of the things that is challenging is, so, we've made it possible for someone with, in the middle of a forest, potentially, in a small village, to receive Vericoin if they have, some cell towers nearby and they have a very inexpensive cell phone. But then what do? They can't really do anything with it. And then comes the computer necessity, really, because you have to transfer your Vericoin to an exchange or to an exchange and trade that Vericoin for Bitcoin, and then transfer that Bitcoin to another exchange, and then cash out. And this assumes that the government is allowing all this. There's not regulation getting in the way of that, and many other factors. So we made it possible to transmit currency to areas of the world with little infrastructure. There's still a major problem, and that is how you actually use it. One option is the merchants just accept Vericoin, but again, if the merchants can't don't have a mechanism for going into their local currency, then they're probably not going to accept it as a form of payment. So to address this, to begin to address this problem, we implemented already this feature called Verifit. And this is an intermediate step. It's a step in the right direction. It doesn't solve the no computer problem, but it solves some of the problems. And that is in the Vericoin desktop or Android wallet, you can basically spend Vericoin as far as the user is concerned anywhere Bitcoin is received. And what's actually happening is the wallet asks you how much Bitcoin you want to send and to what Bitcoin address, just like you're using a Bitcoin wallet. You push send. It pings our Verifit server. Our Verifit server says you will have to use some number of Vericoin that is equal to this amount of Bitcoin. Do you approve? You press OK. And the wallet just sends Vericoin to the Verifit server. And the Verifit server, once it receives enough confirmations that we're confident that the Vericoin is going to be fully confirmed, which is a matter of seconds, then we send on the Bitcoin, the equivalent amount of Bitcoin, to the merchant address that you had intended to send Bitcoin to. And so what ends up happening is this: from the Vericoin wallet, you can send Bitcoin to a merchant's address, and it takes literally like 10 seconds longer than it does to send in the Bitcoin wallet. Essentially, you don't notice the difference.
Can I do that by SMS?
No, currently we don't have that capability through SMS, though we are looking into ways to set that up into the SMS system. Currently, this feature is available in the desktop wallets and the Android wallet. You can basically spend your Vericoin in the form of Bitcoin extremely easily. So that's one of the ways, and this was a brand new novel feature. So the two novel features that I've mentioned so far.
Sorry, can I interrupt for a second?
One minute. One more question.
Sorry can I interrupt for a second just to ask a few questions?
Sure.
Yeah, thanks. So you were saying that Vericoin in the Vericoin wallet, it allow you to send Vericoin to a Bitcoin address, and in doing so, you will convert the Vericoin to Bitcoin and send it to that Bitcoin address. So I'm wondering about two things. So the first thing is like, where do you convert the Vericoin to the Bitcoin? You are doing that, and you are doing that automatically by like exchange, the API on the exchange or something.
Yeah, we're using an API that actually runs on multiple exchanges. The number of Vericoin that's calculated that's required to be spent is an average of the current exchanges. With the top exchange, that's the Vericoin exchanges that have Vericoin with top volumes. It's an average price from all of them that we require, and then we use an API that automatically exchanges the Vericoin for Bitcoin. We've already sent your Bitcoin to the requested Bitcoin address, and then on our back end, automated, we then refill the Bitcoin wallet with the Vericoin that you sent us. Actually, it's an automated system.
So
it is a centralized server system. It's not decentralized. Primarily, the reason is because if it was a decentralized system, it would probably be quite slow unless we somehow built it into the protocol itself, which we don't really intend to do because this is more of an intermediate step to gaining accessibility and usability of Vericoin, not an ultimate step. So to basically preserve the efficacy of the system, to make it worthwhile using it. It's efficient. It gets the job done. We have a Veribit server that is under our control, and that's the downside of it is that. However, it's completely optional. If you don't want to use it, you certainly don't have to.
So, and also when you send the like a Vericoin to the exchange, does the exchange require you to wait for some confirmation before they allow you to use that Vericoin and to change that to convert that to the Bitcoin?
Yeah, we definitely have to wait for. So different exchanges have different confirmation requirements for receiving the coins that you deposit onto the exchange, and we have our own confirmation requirements for sending to an exchange. Yeah, but I mean, essentially, we wouldn't be able to sell the coins if they were rejected by the network. Even if we tried, we really wouldn't be able to do that. That's something that's basically inherent in all decent exchanges. A practical requirement for the number of confirmations before a deposit is confirmed enough that you can actually sell the coins. There's confirmation restrictions.
Okay, but you said that you only take like 10 more seconds than if you send it directly using Bitcoin, right? But when they send a Vericoin to the exchange first, and the exchange need to wait for confirmation, would it not take a while before you get converted to Bitcoin?
So basically, if we get 3 confirmations from your Vericoin that you sent through the Veribit system, then the probability of the rest of the nodes in the network denying that transaction is extremely low. So at that point, we take the risk. It's extremely low risk, like way less than 1%. But we basically, after 3 confirmations, then send your Bitcoin on. So we don't actually exchange your Vericoin before we send the equivalent amount of Bitcoin on to the address you requested. So basically, we just wait for enough confirmations that it's nearly impossible for the network to deny the Vericoin you sent to us. Then we send Bitcoin from our Bitcoin wallet, automated, and then over time we sell Vericoin on the exchange to get Bitcoin back into the Veribit server. And this way, we also can slowly sell the Vericoin, and we have some time control over how long it takes to sell Vericoin, so that we're not negatively affecting the price with this mechanism.
Okay. Oh, but so you guys are bearing the exchange rate risk of this operation there, I guess. In that case, yeah.
I'm sorry, I couldn't hear that.
Oh, I just wondering. So you guys since you guys are running that server, right? You guys are bearing the exchange rate risk in this operation, because when you sell it, because you are sending the Bitcoin first to the you are sending out the Bitcoin before you actually before you before you sell off the Vericoin. That's why I'm saying, yeah.
I couldn't quite hear the last part of your question. Sorry.
Oh, okay, because you guys are sending out the Bitcoin before you sell off the Vericoin.
The Vericoin, right?
Right. Okay. And so you also said that you are using API that works on multiple exchanges.
Yeah, we're using separate APIs for each exchange, coded into our Veribit server system.
Okay, I see. Yeah, so there's no master API for like each exchange or something like that. Right.
No, we have multiple APIs set up for each exchange. Like we have an API for each exchange because they each handle things. They each have differences in their APIs. So we have I think like the top. I'm pretty sure it's the top 5 exchanges for as far as volume for Vericoin that we generate an average price from, and then depending on the current volume and the buy orders and the sell orders, the Veribit server makes an optimal choice for achieving the sell at the correct price and in the timely manner, basically, and that's determined by the volume as well as the buy and sell orders that are currently on each exchange. So we don't know where it's going to sell at any given time. It determines that based on the volume at any given time. And so basically the thing that makes it really convenient and easy to use is that it's like using a Bitcoin wallet, and it takes you basically can't tell the difference between how much time it takes to send out of a Bitcoin wallet and how much time it takes to send and receive out of the Vericoin wallet in the form of Bitcoin. So that makes it possible to, overnight, we have, basically as far as the user is concerned, we have the market penetration of Bitcoin, we didn't have to develop relationships with all these merchants, which we think is kind of, for all intents and purposes, a losing battle relative to Bitcoin at this stage, because Bitcoin has been working on these relationships with merchants for years. Bitcoin has, obviously a much larger network, a much larger user base.
We have another question. Doug, we have one more question.
Okay, so just back to the proof of stake algorithm. I'm pretty new to this, so I know that the feature of it is that it works by calculating your probability of winning the interest based on the coins and the coin gauge. But can you go into a little bit more about the mechanism for how it gets the random winner of this lottery?
Yeah, sure. So basically, the actual transaction confirmation itself is in fact essentially a mining transaction confirmation. It's of the same form. So when a node actually does sign a transaction for the network, it is actually performing mining with the CPU. Because it's a pseudo random that has the primary variables are the number of coins and the age, what I was mentioning before. So there's based on the timestamp, the current timestamp, the number of coins in the wallet, the number of coins that can be staked, which is determined by the coin age, that will it'll basically really calculate the probability of you receiving, of you being able to sign a transaction. And then what happens is an actual, but because the competition for signing a transaction is not due to computational power, the other thing that's random is the difficulty. So the ease of signing a transaction using the script hashing algorithm is also random and variable. So what happens is there can be multiple nodes in the network at one time that have that are able to sign the transaction in the context of the number of coins in the coin age. And in fact, that does happen quite a bit. There's multiple nodes that are both trying to sign the same transaction. Both nodes are trying to sign a transaction with a variable and random difficulty, and which basically ends up being whichever node starts doing it a fraction of a second first, is what it comes down to. They end up having the earlier timestamp, and they will their transaction will be accepted by the network, by the consensus of the network. The others will not. However, what does happen is you can have multiple nodes signing the transaction because they have enough coin age and coin to do it, and the window in which they can sign the transaction is opening. And if their CPU, if that node attempts to sign the transaction and it successfully does, then you can actually earn an interest payment. Your wallet will show you earned 0.2 Vericoin. Then the network will actually not confirm that transaction. After that transaction has been fully confirmed, you may have an orphan transaction. And this does happen, in which case what happened is there was multiple nodes that were signing the transaction at the same time. One beat the other, and by the time the sign is distributed across the network, the one with the earliest timestamp won. And then ultimately what happens is the interest earned by the other node was rejected.
Right. Okay.
And this does happen. It should happen. It seems to happen less than 10% of the time, and it really shouldn't happen more than that. Though there is a bug actually in macOS 10 that we're working on that relates to this, where if the screensaver comes on in macOS 10, it somehow has an effect on the network, how connected the computer is to a network. So if your screensaver in macOS 10 flicks on at the wrong time, you can sometimes get an orphaned interest payment. But the way the algorithm works is you still have a certain amount of coin, and if your interest payment wasn't confirmed, then your coin age was not actually reset. So then the next time you earn interest, it's significantly more. So the mechanism is a pseudo-random function that enables a certain coin profile to hash the function, and once that occurs, then you're in competition between the other nodes doing the same thing at the same moment, and then whoever does it first actually earns the interest payment and actually signs the transaction block.
So what's to stop me from owning a significant amount of coins and I don't participate in signing the transactions? I just get coin age, and then I come back after a few months and I eventually win and get my reward.
Yeah, so nothing really stops you from increasing your coin age. In fact, that's one of the benefits we see. So, for instance, to actually attack the network with 51% control of the stake, you would have to have I don't know. I have to count. It depends on the network, what the network's current status is. But approximately, you would have to have 30% or more of the total coin and wait, over 3 to 6 months basically keep the coins offline.
Mm-hmm.
And then potentially, still random though, so it's not, there is no guarantee. Potentially, you could sign multiple blocks in a row.
Right.
But each time you do that, you're reaching the coin age. The probability of you being able to continually sign new blocks is getting lower and lower. And if all of your coins have a very old age, they're all going to stake right off the bat, or close to all of them are going to stake right off the bat. So there's mechanisms in place so that you can't abuse coinage.
Is there a drop-off point for the coinage, like past a certain number of months where it doesn't count? So like, if I come back and buy some now, come back in 10 years, I won't have a huge amount of stake.
There is no maximum per se for the coinage, but the interest and the staking mechanism is in the context of a year. So for all intents and purposes, the max is a year. So if you can't, I mean, technically there's elements of the code that consider time frames beyond a year, but the actual chance of earning the actual chance of your node signing the transaction is dependent on 1 year. So for all intents and purposes, there's a maximum of 1 year. Though if you go beyond a year, it does have that figure in the calculation, and that could potentially affect your probability. But in practice, you would really have a super low probability of being able to sign multiple transaction blocks, and that would mostly be due to the fact that all of your coins, if you had a large amount of coin and you kept it off the network and you built up the coinage, then unless you reserve a certain amount of coins that can't be staked, then the vast majority of your coins are going to stake, and the moment they stake, the coinage has been reset to 0. So it's like going from plus,
I get that.
plus 365 to suddenly 0. So the probability is quite low of you being able to gain that. It's theoretically possible.
Yeah, but I mean, I don't have to store all my coins in the same wallet, right? Like I can have a large amount of coins split up into 6 wallets also. So they won't all stake. So that they won't all stake upon signing the first transaction.
Sorry, ask the question again. I couldn't quite hear.
So if I get it correctly, what you're saying is that all my coins will have their coin age reset upon signing the first transaction. What I'm saying is I could simply split them up into 6 wallets when I buy them, and
right. You could, but then you would have 1/6 the network weight that you would otherwise. So you could split them up into many wallets, and then that would lower your probability further of signing a transaction. So basically, if you try and split the coins up, then what's happening is each node is weaker and weaker. If you have all the coins in one wallet, then and you don't have any coins in reserve, then they're all going to reset immediately. And if you have some in reserve, it's basically equivalent to splitting the coins up into separate wallets, which reduces your network weight.
Cool. Yeah, it's about an hour and a half, so I'm sure you're getting tired. But we've got a few more questions. We'll let you go in a short while, all right?
Okay, no problem.
Okay, yeah, one more question.
Just another basic one about the proof of stake. So let's say there's 10 of us in this room, right? And depending on how many coins we have in the coin age, some of us will have higher probability. But how does one of us or a few of us still get chosen to be the ones that can sign?
So the mechanism actually takes place such that there's a difficulty. There's also if so theoretically all nodes, well, not really. Given certain conditions, many nodes could try and sign the same transaction block. But the difficulty has a pseudo-random origin, but is also dependent on the weight of the wallet. So essentially, the time it takes to actually solve a transaction block is also dependent on the wallet's network weight, or sorry, the wallet's stake weight, not the network weight in this case. It's the node's stake weight. So there isn't per se a mechanism that restricts or gives access to certain wallets. It's part of the calculation for signing the transaction block includes in it difficulty readjustment.
Yeah, that's right. It's a difficulty. I remember. Yeah. Okay. Thanks.
Yeah.
So the questions about the proof of stake is so in this proof of stake, right? What are the factors affecting the chance of being able to sign the transaction? Is that you were mentioning that one of the factors is the coin age, and the other factor is the amount of coins you stake. Is that correct?
Yes. Yes.
And are there other factors? And
not really. If anyone's interested, I can show. I can point people in the GitHub after the talk here to the lines of code that relate to it. But
it might be a good idea to send an email with that link at the end of this talk. If you could send me that.
Yeah, sure.
That would be great. Thank you. Yeah.
There's other factors, but I mean, it's just for the system to work. It's not. It doesn't change the only factors that result in a particular node signing transactions is the coin and the coin age. There's other factors in the functions, but they're basically just kind of housekeeping factors.
And the chance will increase as proportionally with the coin age, and also proportionally with the number of coins being staked.
Yes.
And then how I still wasn't sure how the difficulty was derived, and or how the difficulty works in this equation. Is there an equation for this?
Yeah, it's actually the same. It comes in the same form. The difficulty for the hashing is a difficulty for hashing algorithms, just like in proof of work coin or Bitcoin. It's the same equation. It's different in the context of it being script than Bitcoin, but it's the same as Litecoin, except in the case of our system, there is a pseudo-random factor in this difficulty, which is like I said in the previous question, dependent on a given node's stake weight. But I can lead you guys to the code for the difficulty adjustments as well. But essentially, apart from the randomness, it's exactly the same as Litecoin's difficulty adjustment calculations.
Cool. Can I take you to another feature of yours, your credit card? I'm just curious. Is it a real credit card? Is it a virtual credit card? Does it cost money? Does it have fees? Is it Zappo-like?
Right. So what this is we partnered with CoinSys on this product that they're developing. I can't go into the fee structure or anything until they do, but it's essentially going to have traditional banking fees. So this as far as so essentially the mechanism is this, and you can actually see this on CoinSys.com's website. They have a YouTube video where they're going through the entire process with the Bitcoin version of the CoinSys Visa card. They're using it at gas stations, Starbucks, and they're showing you how you load your Bitcoin onto it and the like. But basically, this is the mechanism, and we're going to be launching with the Bitcoin card from this company, and it's like what Zappo is trying to do, though I think this company, in my opinion, is doing it much better. And basically, it's this. They have a mechanism for having regular Vericoin wallets that you can access, that you can connect to their system. And basically, what happens is they're going to have in the background a U.S. dollar exchange for all intents and purposes, and the U.S. dollars that you exchange your Vericoin for is what's actually going to be charged onto what is in reality basically a chargeable Visa debit card.
Got it.
They use the terminology credit card because of the mechanism by which they're actually basically giving the card credit, but
it's a debit.
It's really more like a chargeable debit card. So essentially, in like less than a few minutes, you could have your Vericoin value on a Visa card, and then basically at that point you're at the mercy of the banking system's fees. But I mean, we're not in a position where you can just live only in digital currency. So inevitably you have to convert digital currency still to your local currency, and in this context, we partnered with CoinSys to make it possible to do this very conveniently.
Got it.
And one of the main things it does is it makes it possible for people to use digital currency in a form that they're familiar with.
Got it.
Yet they still reap the benefits of digital currency. They start to get used to it, or they earn more interest, for instance, with Vericoin than they would in a bank, savings account, or the like.
So I have a question on the market cap, right? So in the last 30 days, your market cap has dropped. And what drivers do you see for Vericoin that's going to actually help the market cap go up? And secondly, if the market cap doesn't go up, what are the transaction fees on Vericoin for a Vericoin transaction?
Okay, so basically the transaction fees for Vericoin are not dependent on the value. I mean, as the transaction fees are static, the minimum is 0.0001. I'm sorry, the maximum is 0.0001 Vericoin. So the transaction fees for actually transmitting Vericoin across the network is actually less if the value is lower. But in regard to your question on the 30-day market cap, there's a number of factors. It's hard to assign it to one thing. I think one of the biggest factors is a factor that has affected almost all alternate digital currencies, and that appears to correlate with the summer, although it's not obvious. But for instance, I'll give you an example. There has been in the context of Vericoin. So there was about a month ago, let's say, maybe a month and a half ago, there was, over the course of a 24-hour period, a volume on one exchange in dollars, like the equivalent of dollars really is Vericoin to Bitcoin exchanging, but the equivalent dollar volume on one exchange of Vericoin to Bitcoin was on the order of $500,000 to $1 million. And right now, in alternative currencies, if you sum up all of the alternative currencies on all of the major exchanges, you'd be hard-pressed to see daily that kind of volume.
Got it.
So to a large extent, we don't think it actually directly relates to Vericoin. We think it's more so a seasonal phenomenon. Also, the Ethereum IPO, which is a very interesting technology and development, blockchain 2.0 kind of technology, meaning it's more generally blockchain applications. That IPO
yeah, got it. That
they raised thousands of Bitcoin. So I think predominantly there's not anything that we directly relate to Vericoin, because nothing that happened really correlates well with Vericoin, pluses or minuses. Mostly it seems to correlate with season and the Ethereum IPO, and kind of is generalized to most alternative currencies.
cool. Does anybody have any questions?
For the card, will that work in US, or will that, and how about international? Well, for the
Does a credit card work both in the US and international?
You know what? I don't know the answer to that question. I honestly I'd have to find that out. I'm not sure.
I'm sure coinsys.com will have that. We can check that out.
Yeah, they should have it there.
Cool. Any other questions here in the room? So, Doug, thank you very much. You've really gone, deep into Vericoin. I think all of us here have gotten an extremely good flavor. I know you've taken a lot of your time. I hope you're not too tired after all of this. It's like over an hour and a half.
No, it's fun.
Cool. Do you have any questions for us?
No, I don't. But I'm really impressed with your questions. And honestly, I had not seen your group before. You emailed Vericoin about someone attending, and I'm really excited actually to follow you guys and watch the other interviews. Really great questions, and this is a new potentially game-changing technology, and it's also extremely interesting and turns a lot of standard assumptions on its head regarding finance and peer-to-peer, what's possible in peer-to-peer networks, even in the context of money and the like. So I'm always game for a good discussion on it, and I appreciate the attention of everybody and the good questions. After the talk, I'll shoot an email out pertaining to the group on some of the specifics of the code that are hard to put into words per se. But I hope I was able to do it to a degree where everyone was able to get the gist.
Yeah, I know. I learned a lot. I'm sure others here learned a lot too. We look forward to that email. If there's anything else we can help you with, if the next time you're in the Bay Area, just give us a call. We're in Mountain View and also in San Francisco. So the next time you're around, just shoot an email, and maybe you can meet a bunch of other crypto folks. And yeah, so that's it.
Thank you.
Thank you.
All right, thank you so much.
Cool.